For this problem, we will first start with a rectangle with the height of 8 and the base of 4. Then we will clone this rectangle, rotate it, then slide it back to our original rectangle in such a way that their opposite corners overlap. The question is, can we calculate this overlapping area of these two rectangles? I would like to thank one of my subscribers, Reggie168, for suggesting me this really interesting problem. Alright, so you can pause the video right now if you want to try to solve this one for yourself and then come back and check your solution. So let's solve this one. So for this particular problem, I will offer you two different methods to solve it. The first method will be using the Pythagorean theorem and congruence of triangles. So let's start by noticing this blue right triangle at the bottom. This triangle has the leg of 4, and we will take a closer look at his upper angle. We can notice that this angle must be congruent to the angle above him by using the vertical angles theorem. So if we now notice another blue right triangle above, you can see that those two triangles have two identical angles. So this means that the other two angles are congruent. Of course, we can conclude now that those two triangles are similar. But those two triangles also have the same leg of 4, since the leg of the upper triangle is equal to the base of our rectangle. This, of course, means that those two triangles are actually congruent by using angle-side-angle theorem. Now we can label the other leg of this triangle as x, and of course, this will be also the other leg of our upper triangle. And if we take a look at the hypotenuse of our upper triangle, you can probably see that our green line and red line together form the height of our rectangle, which is equal to 8. So this implies that the length of the red line must be equal to 8 minus x. Alright, so now if we head back, we can say that the hypotenuse of our bottom triangle must also be 8 minus x. Now we can use the Pythagorean theorem on our bottom triangle. We can say that the leg x squared plus the leg 4 squared must be equal to the hypotenuse of 8 minus x squared. Now we can simplify this by using the formula for square of binomial on the right side of the equation. Then we can cancel x squared and get that 16x is equal to 48, which means that x must be equal to 3. Now we will substitute the value of x, and of course the hypotenuse of our triangle must be equal to 8 minus 3, which is equal to 5. Alright, so now let's go back to our previous sketch. By now you probably already concluded that this red area is actually parallelogram. So, in order to find the area of this parallelogram, we need its base and its height. So the base of this parallelogram is equal to 5, and we can see that its height is equal to the base of our rectangle, which is equal to 4. Now it's easy for us to find the area as the product of the base and the height, so this means that our red shaded area is equal to 20 squared units, and there we have our solution. Alright, so now let's solve this problem by using the second method of using rhombus and ratio. In this method, we will start with the fact that we already know that these two blue triangles are congruent, since we have proven this in our previous method. But due to the symmetry of the figure, this means that the other two triangles are also congruent. So we basically have 4 congruent triangles, which means that the length of their hypotenuse must be the same. But since their sides represent the sides of our red figure, and they are all the same, that means that this red figure is actually rhombus. So we can use this in our favor. We will first pull the big diagonal of this rhombus and label it as D1. Now we will notice that this diagonal is actually equal to the diagonal of our rectangle. And we will use the Pythagorean theorem to find this diagonal. We can say that d1 squared is equal to 8 squared plus 4 squared. We will simplify this and get that d1 squared is equal to 80, which means that d1 is equal to 4 square root of 5. Now, let's pull the other diagonal, which we will label as d2. And this is where the beauty of the mathematical ratio kicks in. Because we know that the bigger and the smaller side of our rectangle are perpendicular to each other, and we also know that the diagonals d1 and d2 must also be perpendicular to each other since they are diagonals of the rhombus, we can conclude that the ratio between the bigger and the smaller side of the rectangle must be equal to the ratio between bigger and the smaller diagonal of our rhombus. Now we can just substitute the value for d1 and get that 8 to 4 is equal to 4 square root of 5 to d2. Now we can just work through this and finally get that the value of the d2 diagonal is equal to 2 square root of 5. Alright, so now we will just use the formula for the area of the rhombus. And this formula states that the area of the rhombus is equal to the half of the product of its diagonals. So we will just substitute the values of our diagonals and work through this to finally get that the area of our rhombus is equal to 20 squared units, and again we have our solution. Well, I hope you guys enjoyed this interesting problem. If you did, leave a like and consider subscribing to the channel for more content like this. And of course, if you have any suggestion for me or if you want me to do something specific in the next video, you can always contact me by email, which you can find down in the description below. And of course, as always, until next time, see you guys and take care.